Alright, so these are additional notes for section 4.3 to 4.5. So in terms of PVA, position, velocity, acceleration. So displacement is how far you are from where you started. So displacement is simply the definite integral of v of t from a to b, where v of t is the velocity function. So displacement is simply the integral of velocity. No need to make any more adjustments. So this takes care of an object that is moving forward, and then moving backwards, and then moving forward again. The displacement will keep track, the integral will just keep track of the positives and the negatives of the movement for an object. Okay? Distance is the total amount a particle has traveled. So what this looks like is we can write it as distance is equal to the definite integral of a to b of the absolute value of v of t dt. So that means even if an object is moving in a negative direction, we're going to keep track of it as a positive. Okay? So distance is simply the integral of absolute value of velocity. So for instance, suppose the graph below represents an object's velocity function. The number inside each region represents the area, or is the distance, the distance covered for that region. Okay, so the 10 represents distance covered, 2 represents distance covered, and 3 represents distance covered. So this object is going to move, let's say this is miles, so it's going to cover 10 miles in the positive direction. Then it's going to go backwards for 2 miles in the opposite direction, and then move forward 3 more miles. Okay. So based on this object's this graph, the object's displacement from a to b would simply be definite integral from v of t dt. So 10 minus 2 plus 3 equals 11. So if he moves, if he goes 10 miles forward, 2 miles back, and 3 miles forward again, then he's going to end up at mile 11. Okay, or he's going to have made forward progress of 11 miles. Okay? The object's distance traveled will be the integral of the absolute value of this function. Okay? So this is how much distance this object covers. So then we're going to keep everything as a positive value, so 10 plus 2 plus 3. So this, so on the odometer, it would show that this car would have traveled 10 plus 2 plus 3, 15 miles. Okay. S of t represents position function, v of t represents velocity, a of t represents acceleration. And this is just further notation from what we learned in the first semester. The derivative of position is velocity, the derivative of velocity is acceleration. So we know this from first semester, right? Position, derivative becomes velocity, derivative becomes acceleration. Okay. So we should be able to go the other direction as well. The antiderivative of acceleration is velocity, and the antiderivative of velocity is position. So the integral of a of t dt will give me v of t plus c, right? Integral of v of t dt will give me s of t plus c. Right? Going back to what we learned from first semester, is we can determine increasing and decreasing speed by comparing the signs of velocity and acceleration. Right? As long as acceleration and velocity have same signs, we know that speed will be increasing. As long as acceleration and velocity have opposite signs, then speed will be decreasing.